After having the case completely described, and now you know exactly what problem you are dealing with, let's check this table that gives us more details about everything. Here in the production capacity, we have in the first quarter, the capacity is 600 square yards, second quarter 300 square yards, and 3 and 4 we see them as 500 and 400 square yards. It means that, for example, here you see the demand for quarter 1 is 400. So it means in the first quarter the manufacturer can manufacture 200 square yards for the coming quarters. So when they manufacture 200 yards in quarter 1, more over to the 400 yard that they needed for that quarter. So they manufacture 200 more square yards. When they manufacture that much in the second square, that the demand is 500, you see they can fulfill the demand because the production capacity in quarter 2 is only 300, but the demand is 500. So how they are going to consider that? And like the previous example that we have done together, we always choose a small problem for the learning purposes. But you can imagine when there are many products and there are many options, you cannot easily decide about the production. And another point, here we didn't consider the situation in which you can dismiss the demand and pay the fine for that, because sometimes the manufacturer prefer to pay the fine for not satisfying the demand because the cost of overproduction or the cost of storing is more than that fine. For the production cost at the first quarter is very cheap too, but the production cost at the second quarter is 5. So most probably when we solve the model that we will do in the classwork, most probably you will find that the capacity for the first quarter is gonna get completely consumed, and because it is cheap, and here but the second quarter it is expensive, but just manually I told you what will happen, because here we have a production capacity of 600 and demand is 400, so we can manufacture 200 more, and here the capacity is 300 and demand is 500, so we can use this extra manufacture 200 square yards of carpet for here. Okay, I think we are good. Let's go to the first activity. The first activity, I can tell you, is maybe the most challenging activity we have here. It says draw the diagram of the scenario we reviewed in the previous page. As was discussed before, we always said when you have a network type of models challenge, it is really suggested you first draw the graph, because when you draw the graph you can put all the information in that graph and you can have a holistic type of perspective on the problem you are dealing with. So when you want to draw the network, let me give you some hints about that. Here again we have some origins and we have some destinations. The origins, there something that supply, okay, supply. The destination, some sort of demand. And so we have on one hand production, on one hand we have manufacturing, on the other hand we have demand. And also another point that I can tell you before you pause the video and start drawing the diagram with all the information that you got from the previous 2 pages is that here, my friends, some of the demand points are gonna work as a transshipment point. What does it mean? As we noticed here, the production in Q1 is cheap, okay, and we have capacity that is higher than the demand. So you, from the start point of here, manufacture 400 square yards of carpet, but also you consider that 200 extra and you send them to the next quarter. So the demand part of these can also be defined as a transshipment point. I'm just giving you as hints. Take your time. As you can see, if you are following me with the PowerPoint that is uploaded on Canvas, you see, as here it is mentioned, the next slide is the answer, but try your best to draw something that makes sense to you for the educational purposes. And when you are done, check the answer or play the video. Let's check the answer together. Okay, here is our graph. Network model. Why network model? Because we have several starting points, origins, and we have several destinations. As you can see here, production nodes, and here are the demand nodes. So simply, it considers 4 quarters as the origins. So you see Q1 production, Q2 production, Q3 production. Let me make it in this way so you can follow me. That when I refer to them, Q1, Q2, Q3, and Q4. And the name of these are 1, 2, 3, and 4, the name of the nodes. Also, about the capacities that we talked, 600 is the capacity of Q1, 300 capacity of Q2, 500 capacity of Q3, and 400 capacity of Q4. On the other hand, it goes for exactly the same quarters, but this time for the demand. So in fact, the transportation, in fact, the movement is inside each node, inside each quarter. So from production in Q1 as the origin to Q1 demand as the destination. Okay, the demand also according to the tables are 400, 500, 400, and 400. Another point that we have on this demand on this table is the production cost that we said for the Q1 is cheap, but for Q2 is expensive. So when you connect Q1 to Q1 production to Q1 demand, over there you put the production cost over there. I agree with you if you are wondering how smart is this graph in drawing and considering all the points. And also pay attention to the smart way of naming them. 1, 2, 3, 4 are all for the production quarters, and 5, 6, 7, 8 are for the demand quarters. Just one point that is the most innovative point of this category of problems is about transshipment, because so far it has been very similar to the previous one, but it is for the first time that we have a demand point that is a demand point and also a transshipment node. It is the first time that we are doing, because in the previous times, either in the shortest route problem, in the maximal flow problem, in the supply chain problem, in all of them, the nodes were either origin or destination or transshipment. Or for example, for the generator example that we did together, we had some cities as the demand points and some cities as the transshipment point and some cities as the supply point. There are also other examples that you can find over there that they consider, but I'm talking about the things that we discussed together. I'm saying that it is the first time that we are discussing such a problem together. I'm not saying that there are no that type of problem. For example, you see supply chain problem, that the point that a city cannot be both demand city and transshipment city. Yeah, it's possible, but this is the first time that we are discussing it. The reason that your textbook has selected this type of examples in this way wants to cover all the different situations with different cases. That I guess it's a very strong point of your textbook that is considered for, that is the main reason that is considered for this course. So it is for the first time that we see a point, for example, a node 5 that is Q1 demand is both a demand point as well as transshipment point. About the demand points, it's quite obvious. You should be fine with that. But about the transshipment point, it is that way. Okay, when it gets some points here, when it gets some carpets here, okay, it starts satisfying this demand of 400, and after that start to send the rest to the next quarter. So when we want to define the decision variables, we need to be careful about their definitions. Very soon we are going to get to that activity that we start talking about the decision variables, but be careful about the explanation on them. For example, x15 and x56, what would be the explanation for those ones? Okay, and now here we have activity 2 that says how many decision variables do we have for this problem and what they are. Pause the video, do your best. About the question that how many decision variable do we have for this problem, when we check this slide, we can quickly notice that because each arc, similar to the previous network models, represent a decision variable. So here we have 1, 2, 3, 4, 5, 6, 7 decision variables to decide how much to manufacture in Q1 to be used in Q1. How much to produce in Q2 to be used in Q2. How much to produce in Q1 to be transformed to Q2.